Hello and good morning, CTS266 Section 840 students for the spring 2016 semester at Anne Arundel Community College. This is the CCNP Switch course for Cisco Networking Academy, and this morning's video tutorial is going to be on Discovery Activity number 10 out of our Cisco Learning Labs curriculum. And this is a great activity to kind of ease us into not only multi-layer switching, but inter-VLAN routing in general. And what we're going to be talking about today is router on a stick. And so as you can see, we've got our topology here. And to give you a little background, again, just to kind of review, remember if both of these ports were in the same VLAN, if this was just simply VLAN 10, then typically that would be an access port, right? And it would be an access port in VLAN 10, and then our IP address here would be something like 192.168.10.1. And this would also be the default gateway. So when these hosts were configured, you would put an IP address. Maybe it's getting its information from DHCP, but you would put an IP address on here and the subnet mask, and then say that the default gateway or the default router would be this 192.168.10.1 address. And both of these PCs, when they go to forward traffic to a network that is not in their local routing table, they're going to send that traffic to the default gateway. And this setup works great, right? But it only really works if we're talking about VLAN 10. If I were to say, here's PC 3, and PC 3 gets added in, and this is VLAN 30. Well, now we have a problem because this is an access port in VLAN 10 in order to get to the router. And let's say, obviously this router goes out here. We'll say this is the internet here. So any traffic in VLAN 30 is not going to be able to route to VLAN 10, right? It can't simply bridge from VLAN 30 to VLAN 10 in order to get out to the router. And then even when the traffic came back, we would have a problem because, again, this address right here is in VLAN 10. So how is this going to work? Well, we've got a couple things that we could do here. The first thing that we could do is, in the hope that maybe there's an extra available port on the router, is do the exact same thing that we did initially, which is we create another access port, which is in VLAN 30, and that is the access port in VLAN 30, and then we give this the 192.168.30.1 IP address, and we assign it to this port right here. Now, you can quickly see where this is going to become a problem. So with one VLAN, the answer is the original drawing, right? With two VLANs, this is a possible solution if we've got an additional port on the router. However, what happens when we're talking about 5 VLANs or 7 VLANs or 10 VLANs? Then, if we're following this sort of architecture, we're going to have to start dragging ports from a router that may or may not be able to facilitate this, right? For every VLAN, we need to have another link come in. An access port needs to be configured for that VLAN, and then we have another IP address assigned to our new ports, right, to represent that VLAN. Because remember, a VLAN is a subnet, is a broadcast, I'll just say bcast, is a broadcast domain. And so it all depends on your use case. If you only have a single VLAN, like maybe at your house, then something like the original drawing would work great. Once you start to add VLANs in, right, to segregate your network out in the different segments on the network, then you need to start to think, well, how many VLANs are we going to have? And so that's what this lab is going to be about, is really the use case where we have enough VLANs, or we're going to have enough VLANs in the future to where what I want to do is we're going to make this a router on a stick. And so this would be a trunk link, because remember, by definition, a trunk link is allowed to pass traffic for more than a single VLAN. Remember when we said that if we only had a single VLAN, we could make this an access port, right? And that this is just simply a routed port on the router that we assign the IP to. Well, if we would like to have this link pass traffic for more than a single access port VLAN, or for a single VLAN as an access port, what do? Exactly. Just like when we're going between switches, and it doesn't have to be layer 3, right? At layer 2, in order to pass additional traffic, or I should say more than a single VLAN, we create a trunk link. So that's what we're going to do here, and we call that the router on a stick, right? Because if you look at it, it looks as if the router is on a stick here, like a lollipop. So let's go ahead and let's dive in here, and we're going to go ahead and set up sub interfaces on router 1 to get our configuration set up. So let's go from user exec into privilege exec. Oops, sorry about that. Go into privilege exec, and then let's get into global config. Now, if I were to say show IP interface brief, or do show IP interface brief, you can see that we've only got 4 interfaces on this router. So if I were to come to you and tell you we're getting ready to deploy this router in an office, and we need support for 6 VLANs, you would be forced into a router on a stick scenario here, or you would need to get a multi-layer switch. But we'll talk about the multi-layer switch later, because right now we're talking about having this this separate router that we're using. So we're going to go ahead and say show run int. We want to look at Ethernet 00. I keep forgetting the do there. And so right now, that's what Ethernet 00 looks like. Not much of anything. So let's jump in there. Interface Ethernet 00. And here's what we're going to do. Remember, we're creating a sub interface. Now, when I put that .10 there, it doesn't have to match the VLAN number, but it is a very, very good idea to do so, because if you ever had to go back and troubleshoot things, you want to try to keep it in sort of a logical setup. So for VLAN 10, we're going to use .10. For VLAN 20, I would use .20, and so forth and so on. So we're going to say interface Ethernet 010. Now, we need to set our encapsulation, and if you look, if I say encap and do a question mark, the only choice available to us is .1Q. The discovery activity encourages you to use .1Q, and I want to echo that. In any modern network, you want to be using 802.1Q for your trunking encapsulation. So let's go ahead and set this up. We've got a sub interface created here. We're going to say encapsulation .1Q 10. Now, that does need to match the VLAN number, because that's the VLAN tag that this sub interface is going to be looking for when traffic is coming in from the switch over the trunk link. Remember, when we go back to the diagram here, we're going to have multiple VLANs coming up, right? So I believe PC1, I think we'll just say it's VLAN 10 for right now, and we're going to be having VLAN 20 traffic, and it's all going to be traveling over this trunk link. So when that traffic arrives here at the Ethernet 00 interface, this interface needs some method to differentiate, is it VLAN 10 that's the sub interface that I should give this traffic to, or is it VLAN 20? Is that the sub interface I should be giving it to? And that's why we have that command here, the encapsulation of .1Q. And that's why that information needs to be configured here, and whatever we say for encap.1Q, that number needs to match the VLAN. Now, the number of the sub interface does not. I'll repeat that again. It does not. I could have easily said here, when we went into the interface config, I could have easily said interface Ethernet 0/0.2 and then use that for VLAN 10. But that doesn't make any sense, right? We want to make sure these things match so that if we ever have to go back, on and take a look at what we were doing to troubleshoot things, that it makes some sort of sense. So let's go ahead and hit enter. And now we're going to assign the IP address, right? The layer 3 address. This is going to be the default gateway address as well for the VLAN. So it's going to be 10.0.10.1, and we're talking about a /24 CIDR notation. So, excuse me. So now when traffic shows up here on Ethernet 00, when it's tagged with VLAN 10, it'll be handled by this Ethernet 00 sub interface, which is Ethernet 00 Ethernet 00.10. So now what we want to do is we want to create another sub interface under Ethernet 00. And if you were thinking VLAN 20, you guessed right. So we're going to say interface Ethernet 00.20. Now, there is an order of operations here. We commented on this in class. If I were to try to put the IP address on to 10.0.20.1, and we'll make it the /24 that it's supposed to be, we're going to receive an error message back here, and this is an important message because, again, it gives us some additional insight. It says configuring IP routing on a LAN subinterface is only allowed if that subinterface is already configured as part of an IEEE 802.10, IEEE 802.1Q, which is what we're doing, or ISL VLAN. So when we do this sub interface, before we put the IP address on there, iOS is going to force us to indicate what kind of encapsulation are we going to be dealing with. And so keep that in mind, that you have to put the encap on first, right? So encap.1Q20, and then we can assign the IP address, and everything is going to work out just fine. So on step 3, it's now asking us to configure a sub interface for the native VLAN. And again, remember, the function of the native VLAN is that if we have untagged traffic that shows up, it's going to receive the tag, the VLAN tag for the native VLAN. Now, they're showing VLAN 1, and to be honest, you should never use VLAN 1. VLAN 1 should be shut down from a layer 2 and a layer 3 perspective, because remember, even if we shut VLAN 1 down and we're not using it on the switch side, all of the control plane traffic, VTP, CDP, spanning tree, LLDP, all of those control protocols which are associated with VLAN 1, those are still going to be communicated across those links. So what we're going to do here is we're going to try to follow a little closer to a best practice. So we're going to say Ethernet 0/0 and pick anything other than VLAN 1. So we'll say 0/0.99 is going to be our native VLAN. So I would say encap.1Q 99, because I'll create the VLAN 99. Oops, sorry. And we left off the native, right? So if any traffic shows up here, it's going to be tagged, that's untagged, it's going to be tagged with VLAN 99. So we'll say IP address 10.0.99.1, and again, we've got a /24 is our subnet mask. So now let's verify. What is this going to look like? Do show IP interface brief. And so there are the interfaces. Now, in the event that the parent interface, and I noticed this when we first logged in, the parent interface here, Ethernet 00, was already in an up state. And that is probably not going to be the case in reality. So if I were to say interface Ethernet 00 and say shut, let's take a look at the impact. Do show IP interface brief. Let's take a look at the impact that that has on the sub interfaces. And so as you can see, if I shut the parent interface down, all 3 of the sub interfaces are also going to be shut down. So let's go ahead and say no shut and see what happens. And we should see, do show IP interface brief, that all of our interfaces come back. So now this also begs the question, well, what if I go into interface Ethernet 00.20? If I just want to shut that down, do show IP interface brief, what happens? And in fact, it only shuts that interface down. So definitely take note of that, because when you're doing your sub-interface configuration, if it's on a net new switch, there's probably a 99.9% chance that that interface is going to be, that it could be down, right, on the router side. So you have to no-shut the parent interface in order for the child interfaces to come up. If you only want to pick off one of the child interfaces to be shut down, then you would simply go into that sub interface and shut just that sub interface down. So do show IP interface brief. Let's make sure that everything looks good, and it does. So now we've got our interfaces configured on the router side. The encapsulation, which is going to assist the router in determining and making a determination as to which sub interface is the parent interface handing this traffic off to, has been done. We have our encapsulation set matching our VLAN numbers, and the sub interfaces, their numbers match the encap VLAN number as well. So now we're going to deal with the switch side of the equation. So when we come over here to the switch, it's really sort of easy lifting here on the switch side. So we go from user exec into privilege exec and then into global config. And we're going to be dealing with do show IP interface brief. Excuse me, and it looks like Ethernet 00 is the interface we're dealing with. And so we can see VLAN 1 has been configured and has an IP, but we're going to create our own VLAN. In fact, let's do that right now. Interface VLAN 99, IP address 10.0.99.1. Oh, I'm sorry, .11. Make it 11 there. Can't be the same as the default gateway address that we used on the router. So /24. We'll say no shut. All right, so we're going to go into interface Ethernet 00 because that's where our connection is. Now, remember, we're trunking on the other side. If I were to say do show interface trunk, we shouldn't see anything right now. If I was to say do show interface Ethernet 00 switch port, let's take a look at what we see right now. Because remember, by default, the ports are going to try to formulate a trunk, because the default mode, at least in this IOU release here, is dynamic desirable. So we've got the dynamic trunking protocol, DTP, actively trying to form a trunk with whoever gets plugged in here. However, what got plugged in was the router port, and the router port, the parent port, right, Ethernet 00, tried to negotiate, or what will happen is the switch will try to negotiate with the other side, with the router, to be an ISL trunk. Then it will try a .1Q trunk, and then ultimately it ends up as simply a static access port. So right now, this port can only pass traffic for a single VLAN, and that VLAN being the access mode VLAN, which is the default, which is VLAN 1. But that's not what we want, right? In fact, we don't want VLAN 1 to go across. We want VLANs 10, 20, and 99. And again, in order to make that happen, what we have to do is we have to turn this access port, right, this static access port right here, we need to go ahead and make it a trunk port. And in addition to it being a trunking port, the encapsulation needs to match. And so we're going to hard code that in here. So we're going to say switch port trunk encap, right, or switch port TED, as I like to abbreviate it, switch port TED, which is trunk encap .1Q. So now if we take a look at the switch port output, and we'll give it a second here, and actually the interface just came up, so we should see something different, and we do. You can see the operational mode, it still says static access, but we have changed the trunking encap to .1Q, although the operational trunking mode is still native. So let's go ahead and say switch port mode trunk, right, or switch port MT for switch port mode trunk. Now let's take another look at that port and see what has changed. Well, quite a bit has changed since before we ran the switch port mode trunk command. So now the operational mode is trunk. You'll also notice the administrative mode no longer says dynamic desirable, because when we hard code it as switch port mode trunk, we are saying, I don't want you to negotiate. You are a trunk port, and therefore you are going to trunk at all times. You're not going to try to negotiate. You're going to trunk at all times. Now, a key point is, even though we said switch port mode trunk, the dynamic trunking protocol is still running, right? It's not until we say switch port no negotiate, which we're going to add in here in a second, that turns off DTP. But even when we say switch port mode trunk, DTP is still running in the background. And it is a layer 2 port, right? Because this switch port enabled means it is a layer 2 port. So what's our administrative mode? Well, the administrative and operational trunking encapsulation has been hard-coded to .1Q. And you can see right here, negotiation of trunking is on. That is DTP. So even when you say switch port mode trunk, it is still negotiating, or I should say negotiation of trunking is still on because DTP is still on. It's not until I say switch port no negotiate, or I'm sorry, switch port, and you know what? They don't have that. We've tried this command before on, I was going to say on IOU, on the Learning Labs switches on IOU, and that command is not here for some reason. But that command does exist. If I were to pull up, and we've actually run this in our labs a number of times. So here's a switch here. If I were to go into global config and into interface FA 101, or is it 001? I'm trying to remember here. Let's say do show IP interface brief. I can't remember the assignments. 101. So if I were to say interface FA 101 and say switch port no negotiate, right? That's exactly what the command looks like. That's what we would want to do. However, for whatever reason on IOU, that command is not here. So we can't turn the negotiation of trunking off. It doesn't appear that we can do that. So that's okay. So again, we've made it a do show run interface Ethernet 00. So we've enabled the .1Q and cap. We've got the switch port mode trunk command. So now let's kind of tighten things down a little bit. We're going to say switch port trunk allowed, and we're going to allow VLAN 99. We'll say 10, 20, and 99. Now remember, even though we haven't allowed VLAN 1, if this was a link between switches, as we've seen in some of the NetAcad labs, that you would still have the control plane protocols that run over VLAN 1. Those are still going to make their way back and forth between switches. So we've got VLAN 10, 20, and 99, and we are not configuring VLAN 1 as the native VLAN. And so again, they've got a nice diagram here if you're following along in the Learning Labs document. They have a nice diagram that shows the traffic flow. And so let's talk about the traffic flow a little bit between the two PCs. And we're going to say that we'll go with the color green here. So when traffic from PC 1 comes up, it shows up here, and it's showing up to Ethernet 00.10. Now, it's the router that can make the routing decision and then send that traffic down to PC2, which is in VLAN. And actually, I should probably switch colors here. We'll go with red. There we go. Which is in VLAN 20, right? But again, all of the magic, the inter-VLAN routing, is taking place here on the router. And it's the same thing in the opposite direction. If PC2 were to ping 10.0.10.11, PC2 will realize that's not on my local segment. I'm going to forward that traffic up to my default gateway address, which is the sub interface on router 1. Then router 1 will take a look at its routing table and say, oh, I have a locally connected, direct connected interface to that network. Let me forward that traffic along because I know how to send that traffic to its destination. And that is really all inter-VLAN routing is doing. But it's critical that this is a trunk link, again, because that is allowing these multiple tagged frames, right, with different VLANs as their tags, to traverse this link right here. Again, if this was an access port, that would not work. It would only work for a single VLAN, and it would be whichever VLAN access we gave to that port right there on the switch. All right, so let's go ahead now. I believe we're going to confirm. And really all it wants us to do at this point is to trace, right? So let's get on to PC1 here. And let's say we'll go from user exec to privilege exec, and we're going to say trace 10.0.20.11, or actually, I'm sorry, the IP is 100. So 10.0.20.100. So the first hop, it takes us to that address that we configured on the sub interface on the router to 10.0.10.1, our default gateway, and then we reach our destination. If I was to ping that address, we'd obviously be able to ping it as well, 10.0.20.100, and we've got reachability. What about the opposite direction? It's pretty much a given that this is going to work because it worked in the first direction, but let's go ahead and just run it anyway, 10.0.10.100, and take a look at that. So PC2 goes to his default gateway, right, which is going to be this 10.0.20.1, which is the subinterface that we created on router 1. So again, when we're talking about use cases, if you think you're going to have more VLANs, and really, when you think about it, what it comes down to is, do I have a need for more VLANs than I have router interfaces? If the answer to that question is yes, that you're going to have more VLANs than you have router interfaces, then if you're using the router and that's a layer 2 switch that has no layer 3 capabilities, this is going to be one very viable solution, is to do a router on a stick. If the answer to that question, am I going to have more VLANs than I have router interfaces? If the answer to that question is no, that maybe you're only going to have 2 VLANs or maybe 3 VLANs, but you've got 5 interfaces on that router, then you need to make a decision. Do I want to do this, a router on a stick, or do I want to get into a configuration scenario where I'm simply going to go ahead and put an access port on the switch like that, and then put another IP here in a different subnet, and put another port off the router down here and make that an access port in its respective VLAN, and use another default gateway address here. And these are design choices that you need to consider when you're setting your environment up. Now, again, you're probably thinking to yourself, well, wait a minute, we've been stressing in class the inter-VLAN routing aspect of things, and you're absolutely right. So if this is a multi-layer switch, layer 3 capable, then we actually don't need that router there at all. And so this is actually a common question that comes up. Well, why would you do this? Why would I set myself up like this if I could just get a multi-layer switch here? I don't need the router. Well, you very well may need this router. Let's say that your connection to get off that network is a serial connection. Because now we've got connectivity concerns. I'm not sure if they make serial cards for multi-layer. So I've never seen a serial card. Not to say they don't exist, but especially in the Cisco product line, I have never seen a serial card that you can plug into a switch, right? In any of the expansion slots. I've never seen that. So if your connection out is a T1 and it's a serial link, right, then you're going to have the router here. And even if this was a multi-layer switch, you still need that router because this connectivity between these routers is only supported between the routers. And so again, this is where it really helps to sort of understand the requirements, how you're going to be set up, how things are supposed to work, and what they're going to look like. Okay, well, this is going to wrap up Discovery Activity number 10, where we took a look at Inter-VLAN routing, and specifically, we looked at Inter-VLAN routing using an external router with router on a stick as our configuration. All right, guys, well, enjoy your week of spring break, and I will see you all Monday night, March 21st. Have a good one.